So you have to bring your phone to the class, especially for the exam. You don't use your phone for the exam, but this happens.
Yeah, test today. I think there's no written test. We need to give exam through our laptop, I think.
So in module 1, week 1, you have a lecture note there. Come on in. So this is our second class. Who of you have attended the first class? Or is there anyone who didn't attend the first class? There are a few, okay. So I'm the instructor. What is my name?
Baek Young Choi.
Like back to the young age, back young is my first name. Choi as in choice, that's my last name. Scroll down slowly. So there was a quiz on the first day. If you couldn't attend it, you need an access code to take the quiz. So you're not allowed to share the code. For the first week, if you talk to me after the class, I'll give you the access code. Okay. So what are the days that you have office hours? About syllabus. I'm asking you some question about syllabus. Last time we talked about syllabus, right? My office hours are on Tuesdays, and TA has office hours on Mondays and Wednesdays. Good, good. Anyone knows my office number? It was not in the quiz, right? 570 G. G as in guitar. This limit. So today we're gonna do intro on cloud computing overview. Okay, so last time we have watched YouTube video on Google Cloud Data Center, right? What are some words you recall from the video?
So,
Any word?
there were about how to cool down the
Cooling.
cooling
Very
system.
Very good. Yeah.
Uh,
Anyone else? Anything else? What's that?
Power gen.
Power generation. Yeah. So power, heating, cooling, the energy
Jupyter.
is a big issue in cloud data centers, right?
Jupyter.
Jupyter, right? It's not Jupyter Notebook. It's not PY. It's a PI. Right? Anything else?
There are chillers, which helps to cool down the whole server system to run the processor and the everything efficiently.
Right. So chiller, again
The
related to
thermal
cooling.
cooling
Right?
system.
Yeah. So
Those
they were
biometric
doing
access.
water cooling, air cooling oftentimes, but there is a oil cooling as well. Later I will show you the data center that I have seen in Texas, the Advanced Computing Center. They use mineral oil to cool down. So computers, the servers are inside of the oil. Okay. Okay. So so last time we talked about the syllabus. For those who have missed, we had a quiz on the syllabus. It's important for you to know just the basic logistics, because oftentimes throughout the semester, students keep asking how many exams we have, when is the final exam. Final exam, we have a date decided by the university, but we might actually do it a little bit earlier. That one I will let you know as the time close. That's what I said on the first day, right? Just the logistics, class logistics. In the first week of the semester, just read it and get it done with it. I told you there is a one thing. If you were to forget everything from the class, there is still one thing I really don't want you to forget. Anyone remember what it is? By the way, I want you to sit in front. Yeah. It's about plagiarism. Thank you. Right. How many plagiarism cheatings are acceptable?
0.
0. Okay. So that's something the university cares a lot about, right? These days, if you just take online class, it's one of the very difficult thing is that the academic integrity. Whether you really attended the class, did the work and learn the concept and knowledge, how to verify it, it's really, really important. So the overall, exams and to generate any work, the academic honesty, scholastic conduct is very, very important, right? Especially in this online era, that's one of the most important things. Okay, before we start, any questions? I don't think I need to use a microphone, right? Let me see. So it looks like there is a microphone with the auto battery or not. Any questions? Yeah, it is working. Wow, it's a very loudly working, maybe too loud. And there's no clip. That means I have to carry this around. Oh, there is another one. So I'm getting used to this classroom. So this classroom, the microphone is something that needs battery. So again, the energy issue. The battery may go out. Is it better with a microphone?
Yes.
Let's use it then. Any questions about the logistics? Now this one doesn't have the clip on the belt. Okay, that I can carry. Okay. So questions? So last time you have two quizzes I have mentioned. One is about syllabus and the other one is about self-intro. right? The self-intro, it is due 23rd, next Tuesday, and access code for that, it's a self-intro with a small s, 0, right, at the end. So, yeah, if you have any issues, let me know. Yeah. How many of you have done it already? Self-intro? Just a couple, all right? So, use the access code, right? And syllabus quiz, the access code is syllabus QQ with a capital, all right? There is another thing that I want you to do is that introducing yourself on the discussion thread, right? So that's on Canvas. Go back. So here there is a discussions thread, and introduce yourself. Vikas has done it, and Harshita, Vikas here. Harshita, maybe next class. So introduce yourself. This is also graded, because I don't have grading. Don't do that. First thing is that you have to. Everything has to be done for you to get the full points. So you added pictures on the profile, like Vikas has done. Harshita has done it yet. It's not done. Okay, so you have to add yourself, add your pictures, and then introduce yourself, and then the third one is responding to others' comments. So read others as well. So please do this by the end of this month. Okay, so those are announcements in the beginning. If you don't have any question, do you? We talked about it the last time. What are the terminology that comes to your mind when you hear about cloud computing? Can we hear again? Any words? You typed it on the chat on the first day, right? What do you, just tell me anything. I'm trying to solicit responses from you. AWS. Then
Public
Azure,
and private cloud.
the GCP, public-private cloud, right? And we also talked about a little bit more last time, right? In the course description. If you are virtual machine, virtualization, right? So those are the things. In terms of the cloud services, so many things these days. They tell me some example. Cloud service example.
Dropbox.
Purpose?
Dropbox.
Dropbox, yes. Cloud storage service. Anything else?
Google Cloud.
What was
Google
it?
Cloud.
Google Cloud, actually, it provides all kinds of services, right?
Yes.
Infrastructure, platform, software, all of them. Canvas is an example of cloud service. Gmail is an example of cloud service. These days, Outlook, Exchange,
Drive.
what's it?
Drive. Google Drive.
Google Drive, yeah. So these days, almost, everything you do works on the internet, on cloud. It's almost hard to find the standalone, the programs, right? So it's really different scene from several years ago. In terms of public cloud service providers, who provides a different type of public cloud services, and that includes AWS, Azure, and Google GCP, right? So when we say so how to use those, you go to this website, create your account, and find the services and use it from there. So these are the websites. By the way, we would like to in the future, maybe even from today to let's do that. I would like to do classroom is big enough, right? Can you make at least one space? Now, some of you, let's do some exercise. Let's make one space in between. So if you are, so this is good. Can you, yeah, space. Or some of you can come up, please. That's what we are gonna do for the rest of the semester. Social distancing. So somehow for our graduate students, I am really open for any questions you might have. You know, what is the access code for quiz again? You know, repeat teaching question is all fine. Just that the topic to your friends, the different class can be useful for your students. All right. Good. Thank you. So these are the websites that you can go to use these services, and you can deploy your own cloud service using, you know, the public clouds. As we are in the U.S., I might be biased. You know, the ones that are based from U.S. I know different parts of the world, like the Chinese Alibaba. Or other cloud providers might be more, you know, popular, right? What is the one that is most popular? For example, the one in the ones in the India, tell me.
It's generally Google and AWS.
What about Indian cloud providers? There must be, right? Or not, maybe in a big scale. So Alibaba, I hear that not just China, a lot of different parts of the Asian countries and some Africa as well, because they offer services at a lower price. So just that I have some, I might have a bias, but these are actually international ones, and you popularly use in the most parts of the world. So using cloud computing services, if you go to these websites, then there are all kinds, so many services. And our goal in this class is not for you to master, you know, these services, not at all. If you want to do that, it's on your own. That's not the purpose of this class. And if you do that, you know, after you know, a couple of years, a lot of things, some services comes and go. It's not just all from AWS. There are a lot of startups that provide and do collaboration with the AWS. For example, have a services, and when the contract is over, or when the usage is not as they anticipated, the services may go. I get emails all the time. Here's a new service, and here's a service that is going to be obsolete. So it's come and go. That's not the purpose of a graduate level cloud computing class. So what we want to focus is on the concept and principles and some basic foundations, and just know that anything, how to use it, those details, it's on your own. Like, you know, assignments, you just do it. We'll provide you tutorials, but you just know that you will have to learn on your own. Anyway, at least you get a glimpse. There are a lot of services there, right? How do you find which one? You can do the search for services, and there are some groupings like a compute. Containers is actually part of the compute right next to it, and there's a storage. Network is actually it's more expensive. It's a less available for general public. I mean, still it is very important. They actually behind the scene, that's what they do, network virtualization all the time. As a services provided for general public, it's not that popular, but there is a virtual, you know, the public the virtual private network services there. You can also search it. But the other things are like platforms and some at the application integration ones as well. Step functions. So these are the things. They have a name like AWS Deep Lens, Deep Racer, Panorama, and anyway, these are their service product names, service names. Azure, they also have a lot, and there are some categories: compute, networking, and storage, and then there are many other things. So among those the three, those are the major public clouds that I want you to experience at least, but that's not the only one. I want you to also try out, Rackspace, the DigitalOcean, many other public clouds out there. But at least I want you to have some feel and experience of the sum of all of those CPEs in this class. So the type of services they provide in all of those three are pretty much similar. In fact, they might look different, but they have all compute network storage services and platform services. These are so-called infrastructure, and there are platforms, and then the application development services there. You can do search too. And this is a Google platform. Here it just doesn't show, but actually it can show. This is just a screenshot that doesn't show there. It also has a lot of those, and you can do a search of the services. Okay. So the why cloud? Because everybody uses it. That's you can say that these days. But the earlier times, when cloud computing was just being born or emerging as a term, we have to, the technologies as well as the general public has to understand why we want to do cloud computing, right? By the way, why is it called cloud? The term cloud. Why not is called box computing or any other words, right? Why is it called cloud computing?
Because everything is stored at a server,
It's
like
far
a
away.
form a cloud, and cloud also stores water. And then we are storing and it's
Everything is water is stored.
cloud stores
You mean physical cloud?
yeah,
Physical cloud?
physical cloud stores water. So it's like I think the concept from, and it's also in the internet. It's not like on the sky. That's why maybe.
The some store the ocean stores water too, right?
Yes.
Yeah. So why do we use the word term cloud?
Because generally the data is distributed in different servers, and clouds act like different sources of
and
the
how
appearance
can
of
you
clouds
link
is
with the cloud? Yeah.
sorry. The
So-
appearance of clouds are a very
Clouds are
good visualization. It's far from us, but it's like accessible.
far from us, accessible. Can you access cloud?
Yep.
The fog is more accessible. The cloud is not really,
It's
but
basically
they're
far from us.
everywhere. Yeah, that can be something. Any other tries?
Cloud is universal.
Cloud is universal.
Everything, like we can access anywhere, remote servers.
Okay, all right, interesting, good, that makes sense. Anyone else? So, what do you think the precursor of a cloud? Before we had a cloud computing, or there's something very important to enable cloud computing is, so if it's not cloud computing, if it's, what's the opposite of cloud computing then? What's it?
I don't think there can be any opposite of cloud computing.
There is no opposite of cloud computing, or can you find an example that is not a cloud computing?
Local devices.
Local device, standalone computer, right? So if you think about the local device computing versus cloud computing, what's the
Internet.
core difference?
Well, we have to connect to the internet to access cloud.
Connecting to the internet. So internet is a thing, or networking, right? So local computing, all the resources are in one box. Cloud computing, resources are scattered, connected by the internet. Precursor of the internet, precursor of the cloud computing is just internet-based network applications, right? So we had my research area is network systems. That's how I can call cloud computing is also my research. So distributed system networking, that's my research interest. When we say the internet, how do you draw internet? You draw internet. What's in the internet? There are end systems like servers, user devices, right? The client and server, but there's other components in the internet, right? What is it? What are they? You need cables, wire line,
Optical
or
fiber.
wireless, right? Links. You need links and other networking devices, right? Like what? What do you call networking devices?
Wi-Fi.
Routers, wires.
Right, routers and switches. Those are not really sender or receiver endpoints. However, they work as an intermediary to receive some information and forward it to somebody else, so to the next node. There are routers and switches, Wi-Fi routers, all the connecting networking devices. There are a lot of networking devices to enable the internet. There are so many connectivities there. So if you draw internet, there are some research work who does internet visualization in terms of connectivity, which is very, very, very challenging to draw entire internet. Even when internet was born really small with just 4 nodes, we could draw it. But as internet gets bigger, there are so many routers and switches, we cannot really draw the internet. And it's not that, it doesn't matter when we say there is an internet network connectivity and there are end servers, right? So in the networking area, we've been using this. What is this? Cloud, all the time. To do what? We don't, so this cloud shape is to simplify all the details, to hide all the details, abstract out just the concept. So it's an abstraction or simplification of the all, the complexities and details. So in the networking area, we've been using this shape cloud all the time. So that just basically means internet. When we draw different pictures, here's the residential homes, and there's the internet service providers, and there is a Wi-Fi. This is also a network. We have been using cloud shape all the time, again, to abstract all the unnecessary details, complexities of the connectivities and nodes, right? So that's cloud computing. Actually, we've been using this cloud shape all the time, and the computing done over the network. That's cloud computing, and to simplify it, well, that's the cloud computing. Okay, so that's where the cloud words come from. I keep forgetting. There is an interesting pop song, about cloud, and maybe I will put it on the video list. So it's not exactly relating to this whole course, but it's interesting. They talk about cloud, how the characterizations of cloud. So the cloud computing, we talked about resources in the course description. Like operating system is about the resource management of a standalone system that includes, what is it? CPU. I'm talking about operating system. All of you, I assume, have taken operating system course. So if somebody asks you what is an operating system, what the course is about, then what would you say? It's about how to manage computer resources like CPU, memory, files. It's a storage. So CPU, memory, the storage system. That is, so those are hardware. How to manage them? The software that manages those hardware, that is called operating system, and that is to support all other applications on top, right? Cloud computing is also manages resources. It's the platform that manages resources, and those resources are compute, processing, right? And memory. What about memory? We put compute and memory together. It's pretty much co-located. It's not connected over, the network. When you say memory, it's a SRAM, volatile memory, right? And then storage, it's a non-volatile memory, over HDD or the SSD. And network is another additional big important resource. So this course is really about the behind the scene of cloud computing, what they do, and the resources they manage basically are compute, memory, the storage, and networking. And then on top of these resources, they build different services on top, and that can be also provided to the users. So these resources, infrastructure, can be provided as a service, and also the other higher level application services or even platforms can be provided as a service as well. So we want to talk about the definition and the trend and the the motivation of cloud computing over the history of the computing and different architecture characteristics. So these are the topics that we want to talk about in the overview section. So I want you to be able to define cloud computing. In university, the academics, we like to define things, right? The people who does mathematics, it's important to clearly understand definition, like discrete math, discrete structure, or even just basic math function. What is a function? You have to know the clear definition, right? That's very important. So cloud computing, you can just say, oh, it's something like, rather than like. I want you to define it in your own word, right? Definition, it has to be really describe the characteristic of the thing exactly as it is. If you were to define an elephant, you cannot define it's an animal, right? Because then fish is an animal. Is it an elephant? No, right? You cannot define it define it in a too general way, right? The elephant, it's about certain size. Well, it's not a definition, because the size range, you might put it as a part of the definition, but of course, if you just specify it is about, the 6 feet tall, or I don't know, what if the younger ones, right? Then it doesn't fall into definition. So when you say define definition, it has to be exactly, the describing what it is. Right? Anyone wants to try definition or cloud computing? or it doesn't have to be a full sentence, but what is important kind of vocabularies you want to put in the definition. Try. You can put the word computing in the definition because it's because there are a lot of other computing models before, but here cloud computing what it is.
The execution of computing services or applications over the internet.
Oh, very good. Yeah, execution of computing services
or
over
applications
the
of
internet. Yeah. So the keyword internet services, right? It's very good. Anyone else want to try?
Cloud can be defined as in remote server where computing resources like memory and power can be accessed anywhere from the world.
Yeah, that's fine. Remote, not a single server. It can run over multiple servers in a data center, and something at your home. If you cannot access it from school, for example, then it's not a cloud computing, right? Yeah. So and anyway, it's good try, but you also try to think and what could be missing. In fact, the Dropbox founders, when he was a student, he forgot to bring his assignment to school. He had it at home, and how about he wanted to be able to access his assignment in the home desktop, and yeah, he could have had the NS network, the attached storage, but he didn't have it, and that was one of the motivations. Okay, so we can. I want you to try defining cloud computing in your own word, and that will be your first exam question. Okay, so these are the for someone who has taken cloud computing course. If somebody asks you what is it, if you cannot explain it, then it's not good. So I want you to be able to do that. I've been teaching cloud computing, I think 2012, but I taught cloud computing as a special topics course in 2011. From that time, if you were to find the meaning of something, probably one of the first things that you will go to is Wikipedia. So cloud computing, it has just become my habit. Every time that I teach, what does Wikipedia say? Here's the definition from Wikipedia. So it's a delivery of computing as a service rather than a product. So service, not a product. Product is something that you own it. Previously, it was like, floppy diskette, or thumb drive, software, for example. It was physically located in something and you own it. That's a product. But cloud computing it's just delivering delivering computing as a service, and the resources are software information, data, all the provided as a utility, like electricity grid over the network. Okay, so that's the definition from Wikipedia. Electricity, you don't have, some of you may have a power plant at your home if you're in a rural area, but probably anyone who had the power plant, small ones even, back at home? Nobody?
Yeah, I have in my. We used to have. Still, we have in our a small UPS or generator system.
Okay. Cool.
In my home country.
Good. But it's a UPS, so it's from the electricity. But
yes.
Anyway, you have your own. Very good. Yeah. For what?
So sometimes my father is a doctor. So it's in Bangladesh. I came from Bangladesh. There is scarcity of electricity sometimes. So he needs to look
Oh.
out the patients to do.
Okay. Yeah,
so
so the patients who lives on defibrillator.
Yes, needs to for the ECG machine, for the use of ECG machine and the electricity for looking out the patients.
Okay,
That's why.
I see. Cool, cool. It's a special case that you have to have a reliability of the electricity,
Yes.
right? Right. But most of the cases, most of us, we don't bother to have that overhead and use it when we need it, and just pay as much as we have used, and that's a utility. Yeah. So computing is used as a utility. Previously, it was really software owned. This PC server, you own it, right? Cloud computing is really delivery of computing as a service, not a product, and all these resources, software, even data information are provided as a utility. And here's a picture from early on. We see what are the things in there. This is a 12. Now what it says is that it's a use of computing resource that are delivered as a service over a network. Okay, so that's cloud-shaped symbol as an abstraction for complex infrastructure contains in its system in the system diagram. So this is a definition. 2013. Now it's a colloquial expression used to describe a variety of different types of computing concepts that involve large number of computers connected to real-time communication network, typically the internet. So you see the even Wikipedia definition, it has been evolving. Probably the picture was at the bottom. I just screen captured the first page. It shows a history of 50s and 60s. Okay. The picture comes again, 2014. It's a delivery of computing as a service rather than a product, whereby shared resources, software, and information are provided to computers and other devices as a utility over a network. So you see the definition has evolved, and then it came back, right? So this is a 2011 definition. Actually, this is pretty good. I want that one, I think. 15 says a model for enabling ubiquitous network access to a shared pool of configurable system resources. So really, the first line definition is trying to capture as is exactly what it is. Just that some things you like it more than the other. Here, another term you see that ubiquitous access through the network, ubiquitous access network, and it's a shared pool of configurable system. Shared pool resource is not dedicated. The opposite of shared is dedicated. This laptop, this server is only for this user, dedication. But this computing resource can be used for user 1 and 2 at the same time, and maybe sometime later by user 3 and so on. There's a shared resource pool. And the resource can be configured. That's a definition. 2017. Actually, interesting thing is that there is some the horse race. Winning horse name was cloud computing, and it has been actually on the Wikipedia for a while. So, so not to be confused with that. Here it says it's a computing infrastructure and software model for enabling ubiquitous access to shared pool of configurable resources, which can be rapidly provisioned with a minimal management effort over the internet. Okay. So another additional term you'll notice is what? Maybe rapidly provisioned, right? So keep showing the same picture. 2018, again, this one shows here is an IT paradigm. So sometimes what is a cloud computing? It's we can say that it's a computing that does something, and the previously it's a delivery of the computing service. And then here it says, sometimes it says the computing model, right? And it says now IT paradigm. It enables this thing. 2019, again, it changed it a little bit. Shared pool of computer system resources and higher level services that can be rapidly provisioned with minimal management effort over the internet. 2020. So the very first word, what is it? This time, on-demand availability of compute system resource, especially the storage and computing power, without direct active management by the user. So it's really something about management is added, like here, minimal management effort. It's a on-demand availability of the system resource that you have seen actually before, right? On-demand availability of system resource. So it's actually staying pretty much the same. Right? Now that's what it's pretty much stays. Now it's not dynamically changing much, but still the content is evolving. This picture comes really from 2011, right? This is from actually this one. So when the word was appearing, it's maybe 2010, 2011. Only 2011, NIST has come up with the definition of cloud computing. What does NIST stand for? What's that?
National Institute of Standard and Technology.
Yeah, right. National Institute Standards and Technology. It's the U.S. the government, the lab that does a standard that actually supports standardization and technology. There are some. They actually support. It's actually under U.S. Department of Commerce because standards is the one that makes the interaction possible. Like if you go to Home Depot, there are a lot of nuts and bolts, the lights, it's all under some standard, right? The smartphone has a lot of standards in it. Otherwise, one company makes everything, which in these days, that is not possible. There are a lot of companies who have to work together to make a different product, and some portion can be replaced and so on. In order for that to happen, the economic interaction, there should be standard. So NIST is under Department of Commerce. I also have some current project with NIST, and they do the standards actually support and also try to define the term. When people say different things to mean a little bit different things, or having a different opinion in their own mind, and they think that they are talking about the same thing, that can happen. So when some new technology comes up, they try to offer the former definition of the new concept. And only 2011 they came up with this definition. And here's the definition. How many lines are there? 5 lines. So I don't think, I won't ask you to memorize this definition for the exam. I want you to just come up with your own definition, but you cannot say just that's a kind of computing. That's not a definition. It's a kind of internet computing. As is, it's not a definition. So you want to include the keywords in the definition, and also you want to have a right, the noun, right? Here it starts is previously the noun, the computing, cloud computing is some noun, and that there are describing adjectives and phrases there. You cannot say cloud computing is a software, right? Previously, we have seen what is computing model, or IT paradigm at blah blah blah, right? Or some on-demand computing, and that there is a more descriptive the phrases. Here, what it says is a model, and what are the keywords here?
Ubiquitous.
Ubiquitous, convenient,
On-demand.
on-demand, network access, shared pool, configurable, resources,
Rapidly.
minimum management, and rapidly provisions. Yeah, all these are keywords. Okay, so it's important for you to, and you weave together. It's a model that has all these keywords, and you put them together. So let me read it for you. The other times I will ask students to read it. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, network servers, storage, and applications and services that can be rapidly provisioned. So without cloud computing, you might have to call somebody. Hey, can you provide this service for me? And your call might be transferred multiple times, and then later you might get responses from the email or by letter mail, and then interaction can take months. Here it's rapidly provisions. What do? You just click, minimum human interaction. So rapidly provision and released with a minimal management effort or service provider interaction. If you have tried virtual machine, you need a machine. Usually you have to search for spec. You have to purchase it. If you're purchasing through the university, you have to get the approval. Payment has to be done, and then shipment, operating system installation, and it can take months. Here it's just a click. The virtual machine deployment can be a minute or so. Or less than a minute. It used to be like several minutes. It depends on what you are doing it. If you are doing a virtual private network, it can take a little longer time, but still in the scale of maximum minutes, not like days. Some things can take actually days. Basically, we use network as a computer. And actually, the opposite is true. Computer is a network. Actually, if you look at inside a computer, it's also a network. But we are talking about the computer as a single node, and then connectivity of the nodes. We use that as a computer. That's what we're saying. So if within a computer there is a CPU, memory, storage, I/O devices, the printer connected. All these are actually connected through a system bus architecture. Car is a computer. Car is a network that has a lot of things attached to it. You can also see that microscopic way, but here macro scale. So in the document, by the way, in our reading list, I also put this NIST document there. It's not just a document that has a one sentence there. It has the description. What are the essential characteristics of cloud computing? So these are the characteristics. Broad network access. Available over all these capabilities are available over the network. Access through standard mechanisms, typically through web browser. Amazon AWS. Why do they call it AWS, Web Services? They didn't say Amazon cloud computing. Cloud computing word was a very, I mean, for you, computing is okay. For general public, it's something scary at the time. But they call it web service. Didn't say cloud computing. In fact, the different companies, Salesforce is one of the ones that popularized the word cloud computing to the general public. I also put that the video on our reading list, and maybe we can see it together in the class later. But anyway, typical access mode is the web. I told you GCP, Azure, AWS, how to access it. I gave you a web link that starts with HTTPS, right? But they didn't say, it is over HTTPS, but the web, it's just an over standard mechanism, so it's general enough. It doesn't have to be internet in terms of definition, but typically internet, that's what the definition says. There has been actually a lot of different networks, different, in the early times or before the internet, there has been different networks in different countries, and even in the US, there has been competing different networks. Apple, IBM, they have their own protocol stack separately for their machine communications, not really universal communications. Over the time, TCP/IP won the battles among all these competitors, and it became the biggest network. It's just an big instance of big network. Doesn't have to be that way. So that's what. But practically, we know that it's over the internet. So the broad network access has to be there for a cloud computing essential characteristic. Other one is people have to use it to be popular. So the usage can be done by various devices and platforms. Thin or thick client platforms. It can be, so client platform, the say laptop, mobile device. These are clients. You access server remotely and receive services, right? It can be high-end thick client or just the small low-end tablet. So cloud computing, the end system client platform devices, it can be various, heterogeneous. It didn't say Samsung Galaxy, the phone device. And then another characteristic is that, what is it? Just I want you to read it. Speak out loud. Resource pooling. And there's another word over here. Everyone say that.
Multi-tenancy.
Yeah, multi-tenancy, or in other words, resource pooling. So if it's not multi-tenancy, it will be single tenancy. That means resource is dedicated. No, in cloud computing, there's a resource that are for many users, multi-tenants, like apartment, right? You are a tenant of apartment, and there are tenants in an apartment sharing resources, like like a gym and things like that. So here, provide this resource of tools to serve multiple consumers, and the resources can be various. Location can be various, and oftentimes the tenants do not really control the exact location. And in fact, when you use the cloud resource, you might actually choose some data center or site, like Midwest one, or the European zone, a certain site. And different data center, in fact, may offer different services. new services. Suppose in the beginning, blockchain service, it may not be available in say Africa or some other reason, because um, there may not be a lot of users there, and it costs um, it costs them for provision those resources. So when they have a new services, they might actually try in some site. So again, some of the resources, the services available may differ depending on the data center sites. So but still, so those things user might choose. You want to have some service, you want to have a server close by near Kansas City, not in the different country. That one can be chosen, but you don't say it is in, um, data center building one in first floor in the first rack and the third server. That's not what you choose. Third server in which virtual machine. That's not what you do then. So you don't give a control to the users in terms of exact location of the resource, but that means it provides location independence. And the implication is that it performs well, and it scales, and it provides a security. And all those major public cloud providers who has been there for many years and have so many users in the world, it has actually, we know that it scales really well. That means that you can scale up or down considering what's the limit of the resource. You almost think that there's no limit in terms of resource they can offer. You just need request as many as you want. I need one server initially, and I want to have 1,000 servers later, can be done. Security, always there's no 100% for sure, but it is pretty good for most of the times that we can assume. So let's see, when we say these things are essential for cloud computing services, for that to be called cloud computing services. Another thing is that rapid elasticity. So, in order for this rapid elasticity, scaling up and down, virtually unlimited amount of resource, basically it's all automated. Configuration is done through all the automation software rather than through a manual interruption. So that's the things can be done without human interruption. In the beginning of the cloud computing, there has been some research papers effort trying to compare what's the my students also try to do performance evaluation. Which one performs better? Which one offers better computing resources these days? And pretty much is the unlimited. But still, speaking about the comparison, I would like to hear from you students, every year, every semester, how you feel about those public clouds. What do you think? What you like? Which one you like more or not? Why? So I ask you a question in the assignment later. That's an important part. I want to hear your comments. And the service has to be, what is it? The word measured. In other words. So this is a service. It's not just a free service. It's a service provided per request, and oftentimes from a commercial entities. So when they provide these resources, it has to be measured, so that users can say, I want more or less, and also provider can say, you used this much, therefore you are charged by this much. So for pricing, monitoring, the pricing as well as the service quality monitoring, it has to be measured. So these are the essential characteristics. Again, the least defined what cloud computing is, and also talked about what are the essential characteristics of clouds: broad network access, and the diverse client platform can be used,
Multi-segments.
and multi-tenancy resource pooling, rapid the elasticity in terms of resource scaling up or down. The services are measured. Okay. So for this cloud computing, there are a lot of relevant technologies. As we talked before, virtualization, in fact, it is a key to enable. Again, our class is a behind the scene, right? How can the resource pooling possible? Well, resource is virtualized. That's how it is possible. And virtualization, hardware, software technologies has evolved. That's how this cloud computing could be appeared. When we had just the internet before, still we didn't have a so-called cloud computing. It's just we have a socket programming, client and server. Of course, it's still it's important parts, but it's not like a rapid, elastic deployment of things. That's something. Those things what you can do now wasn't available before, and the previous internet network program was not really called the cloud computing. We had just a web server, and we have a web browser. That was it. A lot of relevant technologies has evolved together, and that's how cloud computing could be merged as a really useful computing the model. So the other relevant technologies include the server, client, hardware technology, network technology, and data center. So all these the access of resources, and also the APIs. So we need a software backbone engine of the cloud computing, virtualization, and all of the hardware and enabling integration technologies there in terms of both hardware and software. So still, what is I teach oftentimes other class network architecture. We try to define what is the internet, and there are different ways defining the internet. One way of doing it is that what's in the internet in terms of component, and also another thing is that another way of defining things what it does. And similarly, in cloud computing, what's in the cloud computing? We have a network, and actually in the data center, we have racks and servers. It's actually cluster computing. So related other concept is like this, that includes clusters, distributed system, supercomputer, and something that stores a huge amount of data. Right? And you can say so many things. None of the above or all of the above. At least all these things, somewhat related. So these are these previous systems we had before, cluster systems. We still have it in the university, and in terms of technology, we call it cluster computing, right? The cloud computing uses cluster computing technologies. Cluster computing also uses the distributed computing system technologies. But in terms of the supercomputer versus cloud computing, it does a similar thing, right? big computing, big storage, it does. It's a similar in that sense. However, supercomputer is a one big thing versus cloud is the sum or aggregation of many small servers together. So in terms of what it does, it is relevant. And for people who really cares about the data most, it's only the data. It's a data store, you might say that. In fact, when I ask you what's the cloud computing, try to define it, and somebody really, a lot of times students focus on the data application. So if you are interested, using most of those services, that's how you might see that. Anyway, it's almost like a superhero. What's in it in terms of the component? There is a data center, as you have seen before. There are lots of nodes, computing nodes, servers, and storage nodes. Storage nodes, computing nodes, will be all the standardized in a format that can be put in a rack, right? And then they are interconnected. So usually there is rack. There are a lot of servers stacked together. They are connected by a switch that is on the top of the rack. And those switches will be again interconnected with a router, and it will actually form a network topology. So what's in there? And then there is those are hardware, right? So what's in it, and then also there is a software portion. There would be more than one data center across the different geographic location. Of course, if you want to build some company that provides a cloud service, you might start with one, but over the time to cover multiple geographic areas, you might have many in different places, especially for disaster recovery purposes. If there's an earthquake in one place, you want to keep all the information, data still survive in different places. Different sites may have a different structure and services. I told you in terms of services, it really depends on the need and also the scale, the financial resources they can put in, so it can have a different resources. You probably have seen like Amazon Prime Video. They say it's on Prime Video, not available on your site. It's more of the software storage, the provision planning. Maybe not too many people are watching that content, therefore they decided not to invest storage resource in US. Okay, so let's see. I am actually showing a lot of multi-visual coding, multi-coding. That's a part of the learning strategy we talked before, right? So I'm showing the similar concept from a different illustration. And architecture is actually something really important. In the computer science, there are some areas like a sequential algorithm complexity theory. We need to have that kind of thinking. And also another thinking skill or thinking strategy we do in computer science, really architecture one. That's somewhat different from really mathematical. Well, in math, maybe topology, geometry could be different. But different kind of thinking. Architecture view concept, I want you to have it for us to deal when we deal with the so-called systems here. Yeah. Cloud computing system, operating system. Okay. So here's the things that I previously mentioned is all the enumeration. I put it in an illustration. There are storage nodes, the server nodes, and it has to be connected together. It's a one way of putting computing resource integration architecture. Another way of putting it is that here's a hardware infrastructure. And then there will be some, the platforms. Storage can be actually part of infrastructure, so it's but it can be on top. And then there is a software platform, development platform. When we say platform is actually really overloaded word that can be used for different concepts. We say what is a platform? Facebook is a platform. Political, Twitter is a platform for political agenda. So they say we use a platform in many different contexts. In our class, platform is really the software that enables for other software services. So database actually is an example of platform, or app development platform. That's a platform. Okay? And then there will be application built on top. After application, it will be available as a service to users. Client, actually, you might put it over the network, but this is another way of putting the architecture. Okay? Clients will use a web browser or an app. Like even Zoom, you can have the web browser or a separate app. The service is what cloud computing provides as a function. As I said, the platform is a software infrastructure or software that enables others. So that's what I was going to say. GCP is a whole the Google Cloud platform. As a part of GCP, they provide the Google App Engine. And that Google App Engine is an example of software development platform. Okay? So these are the example of platform. By the way, in the quiz, I might give you some examples, like Google App Engine is an example of infrastructure platform. You know what it is. Storage, you might think that these days are all SSD. Well, still we do use a diverse platforms. So I see that we are over time. Let me stop here for today. Again, remember that finishing your self-intro syllabus, please, if you haven't done it, let me know. And then I will, at least this week, I will waive your late penalty. And remember, on the discussion, you have your picture profile. On the profile, please make it visible, recognizable. Don't just put a flower picture there. And introduce yourself and respond to others.